this video, we're going to look at parallel, perpendicular, and intersecting lines. So we're going to define what we mean by parallel, perpendicular, and intersecting lines, and then we will do a few examples that utilize some facts about parallel lines and perpendicular lines, and specifically their gradients. So say we have two distinct lines, L1 and L2, with equations. L1's equation is y equals m1x plus c1, and L2's equation is y equals m2x plus c2. So L1 has gradient m1 and y-intercept c1, and L2 has gradient m2 and y-intercept c2. Now, one of three things must be true for L1 and L2. Either they are parallel, so this means they do not intersect, so parallel lines are lines that run alongside each other without ever crossing over. So here's an example of two parallel lines. Or if they're not parallel, they could be perpendicular, so this means they intersect at right angles. So they do cross over, and they do so at 90 degrees. So here is an example of two perpendicular lines crossing over and forming a right angle where they intersect. If they're not parallel or perpendicular, then they must intersect not at right angles. So because they're not parallel, they are crossing over each other, but not at a right angle. So here's an example of two lines intersecting, but they're not perpendicular. So one of these three things, exactly one of them, must be true for any two distinct lines, L1 and L2. Now we can go a little further and just talk about, specifically for parallel lines and perpendicular lines, we can make certain statements about their gradients. So the gradients are important here. We don't care too much about the y-intercepts, but there are certain things we can say about the gradients of two parallel lines or two perpendicular lines. So for two parallel lines, say we have these two. These are L1 and L2. These lines are parallel, and so by definition, they must have the same gradient. So if you like, you can think of this as definition of the word parallel. It means that their gradients are the same. Because if they're parallel and never crossing over, then one can't be steeper than the other, because if it was, they would eventually cross each other. So we have m1 equals m2 for our parallel lines. We can illustrate that by showing this triangle. We know that the gradient is calculated by dividing the vertical length in this triangle, the vertical side, by the horizontal side, the length of the horizontal side, and we could shift this triangle over here and it would fit onto this line perfectly because they're parallel, so we'd get the same gradient. What about perpendicular lines? Well, say we have L1 and L2 looking like this now, so they're perpendicular lines that cross at a right angle. Well then, it must be true that their gradients satisfy m1 times by m2 equals minus 1. So we won't in this video go into the proof of this, as it's a little lengthy, but you'll just have to take it for granted that when you have two perpendicular lines, their gradients when multiplied together give you minus 1, and this is true of any two perpendicular lines, and it's quite an important fact that you should remember. So let's try and apply this knowledge in a few examples. So example 1. Find the equation of the line that passes through the point 2 minus 5 and is parallel to the line y equals 1/2 x plus 3. So we'll start by sketching some of these things. So here is the line 1/2 x plus 3, or 1/2x plus 3. You can see it's cutting the y-axis at 3, and its gradient is 1/2. So as we increase x by 1, y increases by 1/2. And let's mark the point also. 2 minus 5 is down here, this red dot. So we are asked to find the equation of the line that passes through this red dot and is parallel to this black line. How do we do that? Well, we know that the equation is y equals 1/2 x plus c, where c is the y-intercept. We don't know what that is yet, but we know the gradient must be 1/2, because as we just said, two parallel lines have the same gradient. So if the line we're looking for is parallel to y equals 1/2 x plus 3, it must have the same gradient as that line. so its gradient must be 1/2. So now all we need to do is note that since the point 2 minus 5 sits on the line, it must satisfy this equation by definition. So we can sub in that when x equals 2, y equals -5, and then if we rearrange, we'll find c. So this is similar to what we did in the previous video. So we have -5 equals 1/2 times 2 plus c. Now 1/2 times 2 is 1. If we take that 1 over to the other side and subtract it, we get -5 minus 1, which is -6. So c equals -6. So that's just a simple rearrangement of that equation. So we can bring all this together and say that the equation is y equals 1/2 x minus 6. So we can just sketch this line onto our axes to show what it looks like. So we know it's going through this red dot, but we also know it's cutting the y-axis at -6, which is here. So we draw a line through these two dots, and indeed it does look parallel to the other black line, so that's good. So let's try second example. Find the equation of the line perpendicular to the line y equals 1/4x plus 1, and that intersects that line at the point 4, 2. So we want it to cut the line 1/4x plus 1 at the point 4, 2, and we want it to do so at a right angle. So again, we can sketch some stuff. So here is the line 1/4x plus 1. So this is the line we want it to intersect. And how do we find the equation? Well, again, what do we know about the gradient of this line, 1/4x plus 1, and the gradient of the line we're looking for? Well, if they're going to be perpendicular, their gradients must multiply together to give -1. So if we call m the gradient of the line we're trying to find, then when we times it by 1/4, we must get -1. And then we simply rearrange this, and we get that m is -4. So -4 times 1/4 would give you -1. So this is the gradient of the line we're looking for. So it's now the same trick as we did in example 1. We write down the equation. It's y equals -4x plus c. And we note that we can sub in x equals 4 and y equals -2, because this line is cutting the other line at the point 4, 2. So the point 4, 2 must lie on this line. It in fact lies on both the lines. So we sub this into this equation, so we get 2 equals -4 times 4 plus c. So we've let x equal 4 and y equal 2. -4 times 4 is of course -16. We take that over to the other side, and we get 2 plus 16, which is 18. So c equals 18. So we can write down the equation then. It's y equals -4x plus 18. Now we can sketch this onto our diagram. So here is the point that the line crosses, the line we're given. It's the point 4, 2. So we know it's going to go through this red dot, and we know that it's got gradient -4. So if x was to increase by 1, the y would decrease by -4. So that would mean the line looks like this. You can have a look. If you go along 1 the x-axis, you then go down 4 on the y-axis to get back to the line if you start at the red dot. So indeed it does look like it is cutting the line 1/4x plus 1 at a right angle, which is what we wanted.